Okay, so they gave us a product. We put it on the outside of a product, always goes on the outside of the box. On the inside, we just need to multiply. So for this box, for each of the boxes, you just multiply what's off to the side by what's up above. So I would go 2 times 6 is 12, and x times x is x squared. So 12x squared in that first box. Same thing, second corner, I'm gonna go 6 times 5. 6 times 5 is 30. This just has an x. There's no x to multiply it by there, so it's just 30x there. Down here, I've got negative 11 times 2. Negative 11 times 2 is negative 22. There's an x up there, but none down there to multiply it by, so it's just negative 22x. And finally, we've got negative 11 times 5. Negative 11 times 5 is negative 55. We always want to check and see if we can combine any like terms. And I do see two things with x's without squares, just plain x's. We can't combine this one because it has a different exponent, but these both have x's without squares. So those can be put together, and that's going to end up in our final answer. I'm just drawing a little arrow here. So my final answer is going to be 12x squared. That didn't combine with anything. And then there's 30x and this minus 22x. We got to put those together. So what do you get when you take 30x's and put it together with negative 22x's? Positive 8x's. So plus 8x goes into our sum. And then minus 55. Nothing to combine with that either. So that goes into our sum. And I'm just making myself a note here because this is going into my packet and I might need these notes later. Combine like terms. That's what I did to get this 8x here. How many of us were able to get part A correct? How many people were able to get part A correct? Right. So I'm going to go ahead and work quickly through B, C, and D. And if you're not done, just go ahead and keep working on your own there and check your answers as you go. So part B, we have negative 2x squared times 15x squared minus 3t. That's weird. I did a double take there. They throwing x's and t's in there. Weird. That's all right. We can deal. Now, some of you will do this by distribution. You'll just multiply and multiply. I'm going to set it up like we did in the last one. I'm going to set it up with the box. This box only needs one row because there's only one thing in our first part of our product. Negative 2x squared would go in front, and then my 15x squared and my negative 3t would go on the top. And then we just have to multiply, figure out what goes on the inside, and combine if we can. We got negative 2 times 15 is negative 30. And then x squared times x squared is what? What's x squared times x squared? Close. X to the fourth, thank you. X squared times x squared. There's two x's here and another two x's here altogether. That's 4 x's being multiplied together. That's x to the fourth. Here I got a negative 2 times a negative 3. That's a positive 6. Then I got an x squared times a t, and I can't really multiply those because they're not the same variables. So they're both going to end up in my answer, both an x squared and a t. And I've told you this before, it really doesn't matter what order you put them in, but I recommend that you get in the habit of putting them in alphabetical order. So what comes first in the alphabet, X or T? T comes first. So I'm going to put my T first and my X squared after that. If you wrote that as 6x squared T, that is just fine though. It's technically correct. When you get to algebra 2, you're going to be dealing a lot more with multiple variables and expressions. And you're going to want to get into the habit of putting them in alphabetical order because it's going to make your life simpler. So if you can develop that habit now, well, things are relatively simple. It's just going to make your life easier later on. But it's your choice. All right, so my final answer then goes up here. It is negative 30x to the fourth plus 6tx to the second. And again, some of you might have written that as 6x squared t. That's the same. I've run out of room in my packet, so I'm going to do the last two in my notes. So this is 76 part C. And I'm going to run through this one pretty quickly because it's looking like most of you are finished up by now. So this is the speed that we're going to eventually get to. You should be able to do these relatively quickly. 1, negative 1 squared. Oh, 2 1. Got like terms here. Ooh, I'm going too fast. I'm making all kinds of mistakes. $16 times 3 is 48, isn't it? For those that have done this already. All right. All right, check your answers for parts C and D. And I'm going to ask you here in a second, for those who finished at least 3 problems, to show me on your thumb meter where we're at. And I want you to be good and honest with me. If you're going to need some help with this today, then I want to see an answer that's kind of thumbs off to the side. If you're like good to go and you got 100% on this, thumb straight up. If you're kind of halfway in between, then show me halfway in between. But show me where you're at right now so I can see, because we're going to be moving on today and doing something similar, but it's going to be one step more advanced. Okay. All right. So we're mostly in the learning stage. That's good. Let's go ahead and move on to 77. All right, so if you're still working on 76, go ahead and pause it. That's all right, as long as you got at least a couple of those done. I'm happy. Our goal for today is we're going to be solving equations that have products in them. We can't do that until we get rid of the products. So we're going to work through problem 77A together, A and B. Then I'm going to ask you to do problems C and D. And if you're having trouble at all when we get to C and D, that's where you're going to want to check in with me and get some help. Okay. So 77, part A. And if you don't need your book open at this point, I'll just write it up here if you want to set your book aside. I know those books are kind of clumsy and they don't stay open very well. So I got you. All right, so this is kind of like what we did before, but this time we're solving an equation. So what we did before with our products is still going to be part of the process. But our ultimate goal is to find a value for X or Y that's going to work in this equation. Get that copy down. Okay. That's smart. Okay, so we could do the box for this. Are you guys feeling okay with this whole distribution method instead of the box for these? You guys feeling comfortable with that? I mean, I could, if I wanted to, I could come out here and I could take this thing and I could turn it into a box with a 2 and a y minus 2. And if that's how you're comfortable doing it, that's fine, but try this out instead. Try, if there's just one thing in front of a parenthesis, try just multiplying both things inside by the thing that's up front. What is 2 times y? 2y. What is 2 times negative 2? Negative. There's my first step. Now, if you prefer to set up a box and multiply out with the box, you would have done 2 times y is 2y, 2 times 2 is negative 2, and then that would have come over here. And that works fine, but usually that takes more time. Usually my students will just get themselves comfortable doing it this way. Okay. All right, so we got rid of the parentheses. Basically, now all we need to do is solve this equation. We need to get this y by itself. So what would you be doing first? Would you be getting rid of the 2 or the negative 4? What would you do first? Get rid of the negative 4. We want to do plus 4 on both sides of the equal. Let's do it. Plus 4, plus 4. And those are going to cancel. Now I got just 2y equals, and then we got negative 6 plus 4, which is negative 2. All right, one more step. How are we going to get that y by itself? How do we get rid of this 2? It's multiplying by the y. Divide by 2 on both sides. Divide by 2 on both sides of the equal sign. 2's cancel out. Y equals negative 2 divided by 2 is negative 1. And we think that's our answer, but I'm going to ask you to check, okay? Because when we take our test on this, by the way, it's not going to be until January that we actually check our test. I don't want you just sitting there for 10 minutes at the end of class doing nothing. If you have an opportunity to check, I want you to check. Our original equation, write it down off to the side here, was 2 parentheses y minus 2, but I'm leaving a blank parentheses where that y was. Equal to negative 6. Write that down for me. And what are we going to put in place of the y? We're going to put negative 1 in place of the y because we think y is negative 1. Order of operations tells us to do the parentheses first. So I'm looking at this big parenthesis here. What is negative 1 minus 2? That's negative 3. There's still a 2 out in front there. And what is 2 times negative 3? Negative 6. So I end up with negative 6 equals negative 6. And is that a good thing or a bad thing? That's a good thing because why? Yeah, I mean, it's negative 1 works. We got the same thing on both sides of our equal sign. That makes us happy. That means that our answer is correct. Okay, when you are lucky enough to get a math problem on a test that's an equation, you always want to check your answer if you got time. Now, sometimes you don't. Sometimes you don't have time. But if you can, you need to check. Can you put your phone away, please? Oh, my bad. Where'd you get that calculator? Did I check it out to you? Okay, my bad. I forgot. 77. Part A. Ready for part B? Yeah, we can wait. All right, I like your attitude. Let's do this. Part B. Oh my goodness, we have never solved equations with squares in them before. This is going to be a first for us, folks. It's going to be awesome, though. You're going to do great. I believe in you. And I'm here to help you with this first one. All right, let's get a copy down. Now, I don't want you to be intimidated by this because we have all the tools we need to be successful here. So the first thing we do anytime we see an equation, from here on out, if we see an equation with parentheses in it, that's what we do first. We take care of those parentheses. We know how to take this product and turn it into a sum. It would not have parentheses anymore. Agreed? So that's what we're going to do. I'm going to take this. I'm going to do a little work on it off to the side here. Now, how do we do that? We do that by creating what our book calls a generic rectangle. So draw your little box. We know it's going to be a 2x2 box. Draw it off to the side. Not underneath. Underneath is where our work for the equation goes. So draw it off to the side. And let's put the x and the -1 down the side. Let's put the 5x and the 6 across the top or at the bottom, doesn't really matter. And let's work out what this thing is. If it helps you to, throw a 1 in front of that x. All right, what's 5x times 1x? Would be 5. X times x is x squared. We've got 1x times 6, that would be 6x. We got -1 times 5x, that's -5x. We've got -1 times 6, that's -6. And we'll pause there for a second. What are we going to be able to combine together in our sum here? Do you see any like terms we're going to be able to combine? I like to circle them. I encourage you to do the same. We're going to be able to put that 6x and the -5x together. So let's go ahead and write out our sum here. So I always start with the squared thing, 5x squared. What am I going to get when I combine that -5x and the +6x? What's that going to give me? 1x, positive 1x, right? So plus 1x. Or we could just write plus x, good. And then we've also got our -6 here. Let's not forget about that. And there we go. Now, we're not done because that was just one step of our problem. We have to solve our equation. So let's bring down our 5x squared and our plus 43 and our equal sign. And now we've got a new version of the equation. So doing this was just one small step of the whole process. Now we've got our new equation, and we need to solve this. We need to get x by itself here. And again, some of you might be intimidated because you're seeing x squared and we haven't dealt with that before, but I've got great news for you. Remember how we're allowed to subtract the same thing from both sides of an equation? Let's do that. Let's subtract 5x squared from both sides, right? We can do that, can't we? And if I do that, my equation is going to become much, much simpler, isn't it? That cancels, that cancels. And now my equation is just 43 equals 1x minus 6. We are so close to solving this thing. If I'm trying to get x by itself, what am I going to do? We want to do plus 6 on both sides? Sounds like a plan. And that's going to get me 49. 49 equals 1x, which is just x. So I think 49 is my answer. But I'm going to check it before we circle it. Go back to my original equation. 5x squared plus 43 equals x minus 1 times 5 times x plus 6. And we think 49 is the answer. So I'll put 49 in here, and in here, and in here. And since I got a fancy calculator, and most of you all do, that's good. So I'm not going to bother working this out by hand because those are some big numbers. So I'm just going to type it all in at once. Just this side is 5 times 49 squared plus 43. Wow, that's a big number. 12,048 equals, and then I hope that when I type this in, I get the same answer. Fingers crossed, folks. 49 minus 1 parenthesis 5 times 49 plus 6 parenthesis. Is it going to work? What do you think? You have faith? Hey, same answer. 12,048. Check. That means that our answer was right. All right. Only takes a second to do that, guys, especially if you got a calculator and you know how to use it. Okay. All right. Your task right now is to finish up parts C and D, please. C and D. All right. When you do part C, you're going to have to do 2 boxes. So leave yourself some room. Leave yourself lots of room for C. If you're down at the bottom of the page, you might want to start yourself a new page here. Because you're going to need to do a box for this side. And you're going to need to do a box for this side. All right, get after it. I'm going to circulate and answer questions. Please get my attention if you're having any trouble with these. No. Hang on, I'm about to catch up to you. Know what you got? I'm sorry. I simplified that. They were both divisible by 2, so I divided by 2. Yeah. Oh, then I would put it in my calculator. 5 divided by 2 is 2.5. And it comes out to a nice decimal, so I left it as a decimal. I got the answer for part C up on the board. Check your work. If you didn't get that or you haven't finished that, get that work copy. That's right. That's it. Just a new check. I'm going to actually, rather than distribute like that, I would this is not. No, you did everything right. You made a small mistake on your check. That's always annoying though. Like when you do a problem right, you think you did it wrong because you made an error when you check. Yeah. Do you have a calculator? Does it have like parentheses and stuff on it? So you can let it do all the work for you, you know. Usually the most important time to check is when you're taking a test, right? Oh, yeah, I'll show you in a sec. Give my attention sometime, I'll show you how to do it. Usually when you're checking, you want to check on a test, right? And usually when you check on a test, it's like at the end and your brain's already kind of fried. So personally, I would rely on my calculator as much as possible when I'm checking. So I don't psych myself out and think I did something wrong. All right. Hey, folks, we got one more thing that I need to show you today. So I need your attention up here. If you're not quite done with part D yet, that's okay. This is going to be brand new for all of us. So really importantly, you pay attention today. Well, some of you may have seen it before. We're going to take some quick notes. So this is a pretty easy thing, but it's new and there's a step that you probably haven't seen before. So let me show you this. Our heading would be solving with absolute values. And I'm just going to show you a couple of problems, and then I'll give you some time to get started on your homework and ask some questions. All right, I'm going to start off with a pretty simple problem. I'm going to show you the process that we're going to use. Now, some of you are going to see this problem, and you're going to be able to come up with your answer without doing this process, but you need to learn the process because trust me, they're going to get more complex. These problems are easy to do as long as you know the process. Okay, and the process isn't that hard either. All right, but let's start with a simple one. The absolute value of x equals 5. So this is an equation. And if we're going to solve this equation, our job is to come up with a value of x that I can plug into that equation and make it true. Okay, and I am here to tell you that there are actually 2 values that I could put in place of x in that equation and make it 2. So there are 2 solutions. Does anybody know what the 2 solutions are without actually doing any kind of process? Give me one. -5 is one answer, one solution, and 5. -5 and 5 are 2 answers. Now, that's going to work for something like this, but in a moment, I'm going to ask you to solve something a little bit more complex, and it's not going to be so easy. So let me show you how you could come up with -5 and 5 using a process, okay? The process is important here. So here's the process. When we have an absolute value equation, we are going to split it into 2 separate equations. We're always going to split it into 2 separate equations. The thing in the absolute value stays the same. Nothing changes in that, except we drop the absolute value. So both of my equations are going to have x equals in them. The thing that changes is the number on the other side of the equal sign. One version of our equation gets that number, and one version gets the opposite of that number. What's the opposite of +5? -5. And then we would solve those two equations, which they're already both solved, and that gives us our answer. Okay. So we split it into two equations. Absolute value stays the same. Number on the other side, one version stays the same, one version flips the sign. Let's look at a more complicated example. X minus 7 inside the absolute value this time equals 10. Now, again, I'm guessing that some of you can probably come up with an answer, two different answers for this that would work. Can someone come up with an answer that's going to work? -10. -10 minus 7 would be -17. Absolute value would be 17. That doesn't match. We would want the inside to be -10. What would the x have to be? So if x is -3, that would work, right? That would get you the -10 you were talking about a second ago, right? And that would work. So -3 would work. What's the other value of x that could work here? 17. Oh, you're good at this. All right, so we know that those are going to be our answers, okay? But let's talk about how we can find them using the process. And then I'm going to show you a third example where you're not going to be able to figure it out by just looking at it, okay? Even though you were able to get the last two, like it was no problem. You're really good at these. I'm going to guess this next one you won't be able to do. Okay, but for this one, we're going to do the same process. So let's split it into two equations. Remember, the thing inside of the x absolute value stays the same. Nothing changes except we drop the absolute value. So that x minus 7 stays in both versions of the equation. One version is going to get the 10 that was in the original. What's the other version going to get? A -10. The same thing, but flip the sign. The other one's going to get a -10. Now let's solve these two equations. Any questions about how I split them up? Are we confident on that? That's the only new thing, right? Splitting them up. Are we comfortable with how I did that? Leave everything alone, but then take this, leave it, and then flip it. Okay, now let's solve. I want to get x by itself here. How am I going to get rid of this -7? We'll do +7 on both sides. Those will cancel. What is 10 plus 7? 17. There's one of my answers. And then I got to solve this equation. How am I going to get rid of this this -7? We're going to do +7 on both sides. And that'll cancel. We'll have x equals, this time it's -10 plus 7, which is -3. And there's my second answer. All right. So fairly simple process. Put in the two equations. First one's exactly the same without the absolute value. Second one's exactly the same, except the number flips its sign. All right, here's my last one, and I'm not even going to ask this time around for people to tell me that the answers they think it's going to be. Well, actually, I'll give you a second. I'll let you try. 3x minus 5 and the absolute value equals 16. Anybody come up with an answer here? Anybody? What's an x going to be? Give me an x here without doing the process. What's x going to be? Okay, time's up. You got them? Two answers. Can we come with two answers? Okay, probably a good idea if we could do the process here then, right? Let's do the process. Split it up. Split it up. Both versions are going to have 3x minus 5 equals. And then what about the rest of the equation? This one's going to stay the same. It's going to be 16. What's this one going to have? -16. Always one version with the positive, one version with the negative. -16. All right, go ahead and solve those two equations. It's going to take you a couple steps of algebra to solve them. So if we do +5 on both sides here, we get 3x equals 21. Then divide by 3 on both sides to get x equals 7. 7 is one of our answers. Spoiler alert. See if you can find the other answer. I'm going to give you a hint. It will be a fraction. Just leave it as a fraction. No decimals on that one. All right, so you're going to be doing a few of these problems in your homework. Does anybody have any questions about solving with absolute values? How's your thumb here feeling about absolute values? I'll come back to your question in a second. How are you guys feeling right now about those, though? All right, so if you're here, you just like, I know I'm going to need to practice to remember the process. Are we feeling okay about the process? This thing always ends up in both equations. This is the thing that changes. Always. One version positive, one negative. Question? Oh, that's a great question. Did you guys hear that? So for this one, I think your question was, when I write this down, does it matter which one gets the positive 10 and which one gets the negative 10? Great question. Answer is no, it doesn't matter. So if you put the negative 10 over here, you still would have gotten a negative 3 here, and your 17 would have been here. As long as you're getting the same two answers, it doesn't matter what order you get those answers in. Great question. There is a super common mistake with this. I'll tell you what it is. Does anybody want to guess what it is? Well, lots of my students in the past have made a mistake with this negative 5 right here. They think when they bring it out of the absolute value that everything that's negative in an absolute value has to become a positive. So they would change it into a plus 5. We do not do that. With this process, we're not taking the absolute value of this. We're just writing down exactly what's in here. Negatives at all. The only thing that changes is the number that's on the other side of the equation. One version is going to stay the same, and one version is going to get the sign flipped. But the inside of the absolute value does not change when we use this process. Leave your negatives as they are. If it had a negative 3 in front of here. Oh, that's a great question. So if I had a different